Welcome to this lesson on square root function transformations. Now, I really recommend that you listen and then pause when I direct you to do so to take notes. I also recommend that you use color if you have colored pens or pencils or highlighters or markers available, that you use color to highlight different parts or different kinds of transformations. This will help you to remember and help you when you go back and use these notes to study. Now, let's take a look at the parent function for square root. F of x is equal to the square root of x. The transformations for the square root parent function are exactly the same as the transformations we studied last semester. If there is a negative sign in front of the square root, that is a vertical reflection across the x-axis. If there is a number in front of the square root, that is a vertical stretch or a compression. If the absolute value of that number is greater than 1, it is a stretch. If the absolute value of that number is between 0 and 1, it is a compression. Let's take a look at horizontal translations, moves left or right. If it is x plus h under the square root symbol, the whole graph translates to the left h units. And if it's x minus h under the square root symbol, the graph translates to the right h units. And last, let's take a look at k. This is vertical translations up and down. If it's plus k, the graph translates up k units. If it's negative k, the graph translates down k units. Pause now and copy everything on this slide. And if you can, be sure to use some color. Now let's take a look at our first example. First, we're going to look at the vertex form of the square root equation. It is f of x is equal to a times the square root of x minus h plus k, where h and k tell you the point of origin for the square root function. So we have here 2 times the square root of x minus 1 minus 3. The 2 is a vertical stretch by a factor of 2 because a is vertical stretch or compression, and if the absolute value of a is greater than 1, it's a vertical stretch. The 1 gives us a horizontal translation to the right 1 unit, and the k is a negative 3, so it's a vertical translation down 3 units. Now let's take a look at the effect on the graph of the parent function of these transformations. Now this is a graph of the parent function f of x is equal to the square root of x. This is a graph showing the effect of the transformations. You can see that the curve is steeper because we had a vertical stretch by a factor of 2. It's arcing up at a steeper angle. You can also see that it's been horizontally translated. Now there is a mistake on this graph. This was horizontally translated to the left one, but it should have been horizontally translated to the right one. So it should be right about there at x equal 1. So please forgive me my mistake on this. And finally, this graph was vertically translated down 2 units. Now if I put both the parent function and the transform function on the same graph, you are able to compare and contrast them. Pause now. Copy down all of the equations and words on this graph, and also sketch the examples, graphs. Don't need to get graph paper, just sketch the graphs on your paper. This is our last example, because hopefully you are familiar with transformations by now and can understand this quickly. Again, I gave you the vertex form of the square root function. A times the square root of x minus h plus k. Now, in this case, in this example, we have negative 1/2 times the square root of x minus 3. So let's take a look at that negative sign. That negative sign tells us that we have a reflection over the x-axis. In other words, our graph is going to be reflected. It's going to be upside down, so to speak. And that we have a vertical compression by a factor of 1/2. The absolute value of negative 1/2 is 1/2. And if it's between 0 and 1, then we have a compression. And finally, h is 3. So we have a horizontal translation to the right 3. Now again, here is our parent function with its origin at 0, 0. Here's what the transformed graph looks like. You can see that it's been flipped upside down. That's the vertical reflection over the x-axis. You can see that it's flatter. The arc of the curve is not as steep as the parent function. That's because we've compressed it towards the x-axis. And finally, you can see that it is shifted to the right 3. Now, if we graph both of those on the same grid, you're able to compare them, and that's what they look like. Pause now and copy down the vertex form, the equation, and what each of the parameters means, and also sketch the graphs. This is the end of this lesson. Please note any questions you have, bring your notes to class, and be ready to use them to do the activities.